Thank you, Matthias, for having me here. So what I would like to say is actually a few things about what happened in Germany. And one thing that I think is really important and was also mentioned by Dirk right a second ago is the speed of response. So that's actually a thing that was a big role for modeling. So we do predictions and we can tell what will happen in the next 6 to 8 weeks, as you say. Probably we are more or less right with this. And this information could be used in order to be faster and faster than the virus. But what was happening is that many politicians were listening to those models and then taking the decisions when the predictions were coming true. So this is somehow losing the advantage of the modeling, and was a kind of frustrating element of the whole pandemic mitigation process. The other thing that came up during the pandemic fight was the discussion that there is a contradiction between the interests of economy and health. So this is something that is actually not true. And Cecile covered that yesterday. So I have a corresponding work on this that's published together with the IFO Institute, where we show that actually the health and economy have the same interest, and that the economy is better off in the end when they follow a low incidence strategy. But as Cecile Philippe was talking about this yesterday, I think, or earlier in the conference, I will not talk about that, but I will talk about another problem. And the problem that I would like to focus on is the no COVID strategy and why it was not so much accepted in Germany. So there was a main argument. The main argument was Germany is not an island as Australia. And also there is lots of people traveling between different regions of Germany. And so what we did in order to contribute to that discussion is to do a mathematical model and to simulate exactly this traveling within Germany, and to see whether the no-COVID strategy is still feasible in such a traveling. So we have for every county, which is a node on the right-hand side, every county we have an own model. That is about the infection dynamics within the county. And then we have people traveling between the counties. Mostly this, we were taking data from commuters between the different counties. And for each of those counties, we have a model that is shown on the left. So it's a very simplified version of something that we published in a more complex way in the BMC Medicine down there. And so we used those models in an aged resolved way. So now we have space resolution because the model is for every county, and we have age resolution because we have different age classes. And so if we do so, I have to say a little bit what we do about the commuters. So people can now move from one county to the next. And if they do so, we can combine that with commuter testing. So testing commuters before they actually go to the other side, to the other county. So this is what we implemented, and we have the different states, and the results of those tests are then preventing the people to travel. So if we do so, we can now distinguish different scenarios. One is about the lockdown strictness, so it's how you reduce contacts. This is done in an incidence-dependent way. So if we go with an incidence above 100, there is a reaction and we increase the measures. This can happen with delay that you can see on the right-hand side. So either 1 week delay or 3 weeks delay. So this is the delay of the political decision. And we can do the commuter testing with different frequency. So let's see what happened. We can play with all these parameters, and we did so, but I will just show you a few results that makes sense maybe. So we start here from the map of Germany, where the color is coding the current incidence. It's a random distribution of incidences that we use here. And then we take a very strict version, so strong measures, 5 times testing of commuters, also 5 times a week, so every day basically, and a fast reaction to increasing incidences. And what you can see is that the red parts on the left-hand graph are now turning orange, yellowish, but what is more important, the green parts stay green. And so it means that we were able to protect the green zones with those measures, rather than to, in comparison, if you have a longer delay and test only twice a week, a little bit less of measures. So the red parts are a little bit mitigated, so the originally red parts. But what is more important is that the green parts turn orange. So we now get into the situation on conflagration and lose the control of the pandemic, which means in the end that we will have to do global measures on the whole country rather than to do local measures as we do with a no-COVID strategy. So what that very simply tells you is the no-COVID strategy works. If you have commuters, it will not prevent it to work, but it will require additional testing. So we need the testing of the people who are walking, traveling between the different counties. And the other thing that turned out relevant in this particular setting is that the political decisions are happening very quickly. So the goal here is preventing global measures, and this is the main advantage of low incidence strategies. So I would like to thank the German Aerospace Center with whom we did this modeling, and the No-COVID expert group, who is basically here in the discussion. And that's it. Thank you.
Thank you very much, Michael. Yeah, we had a discussion yesterday about if the science is so clear, what the hell is going on in the world? And I keep asking myself this question